I'm Joshua Held. I'm a mechanical engineer at Facebook. I helped design the mechanical form factor of 3.0. And it's been a really collaborative community effort to do this, so I think it'll be interesting for you guys to see kind of how it went. This is more of kind of the story of the collaboration that we have with the community in order to get this done. We're still actively working on this though, so if you want to get involved, certainly reach out and we can definitely get you involved. Okay. So the agenda today is just an overview of the project over the past year, as well as NIC 3.0 mechanicals and thermal. Just to give you a sense of what NIC 3.0 is, all the work we went through to make a really complete spec to really lower the barrier for adoption across the community. So first, I want to give you some background on kind of how OCP NIC started. The first OCP MES was V.5, and that is there a NIC card there? It's right here. Got it. That was done in about 2012 or so, and it looks something like this. So it's just a small card, and it only had a by 8 on it at the time. So we were a bit constrained in that way. So not soon after, in 2015, we worked on V2.0, and 2.0 actually just increased the to a by 16. Instead, that was the main functionality, but the form factor remained largely the same. We added a second connector on the connector, or a second connector on the board, excuse me, and just to increase the amount of PCIe that we could get up into the MES. So that's pretty much what 0.5 and 2.0 look like for the most part. So just at the end of 2016, we started to see some limitations around 2.0, and we started to really think about what we need to do to get to the next step of kind of where NIC would need to go. More bandwidth, less thermally constrained. These cards are very thermally constrained because they're very tight in a mezzanine configuration. The cards are actually upside down. So if you have a baseboard, it's kind of, I have to hold the mic at the same time. So if you have a baseboard, the card's upside down under the baseboard, so you have to pull airflow basically under the card and then through a small slot in the back in order to cool it. And we were seeing quite a few limitations around that. And then the other thing was board space. This is a pretty small card, so it was very difficult to deal with the board space constraints that we had. So the next slide, okay. The next slide is kind of about how we structure the 3.0 milestones. So as I said, at the end of 2016, that's kind of when we really started seeing those limitations and really started thinking a lot about how we wanted to engage with the community, as well as some of the features we needed in order to support future community need. And then kind of Q1 2017 or so, we started to define the problem statement and setting up the design bounds. So the next thing was solution exploration. This is kind of where we got involved with the community. We started basically, looking at different form factors, different configurations, different connector configurations, all sorts of different configurations to really see what we want to move forward into a spec. And then we got into spec drafting and kind of where we're at today, implementation and refinement. So we're just at kind of the tail end of number 4 here today. So the step of defining the problem was actually really interesting. So what we did is we actually sent surveys out to the community, and I know these tables are kind of small, but the purpose of these surveys was to understand the feature sets that the community would need in order to have very strong adoption for 3.0. So when you look at this table, on the left-hand column, you see the 90-10. That's kind of a probability, like that's a high probability column. And then we have 50-50 confidence. This is much lower probability, but kind of nice to haves. So we did this across the community. So this is actually just an excerpt of one of the tables. So tables were much longer because we would anonymize all the feedback from the community just so nobody could see anybody's feedback to help the sharing a little bit more. So this table actually stretched way out here. We had a lot of input that helped us kind of drive the spec creation going forward. So this is kind of an excerpt of some of the form factors that we developed through this process. So we actually developed 14 different mechanical solutions entirely. Some of these solutions looked a lot like 2.0. So they were actually kind of a plug-in replacement for 2.0 with maybe some additional connector. But some of them look radically different, using radically different connectors and no backward compatibility. So we ended up getting through a total of 14 different solutions. So we had a huge, it was actually kind of funny, we had a huge PowerPoint slide deck with all these 14 configurations, and we'd go through them with the community and see what kind of resonated with people. And sure enough, the 14th one is the one that won out. So the very last one that we thought of was the one that we actually ended up moving forward with. I'll get into some more particulars about that form factor. So just to kind of highlight the collaboration that we had, this was a Texas-Dallas workshop that we had in the US, September 25th in 2017. This was pretty much the first meeting of all the community members involved. So a lot of system vendors, a lot of NIC vendors, connector vendors, and us, trying to get together as a group and really understand what it is the community needs to move forward into the future. And it really helped kind of kick off a greater sharing, throughout the year. That's what we needed really early on in the project, was to get buy-in so that people were really invested in, putting some work into creating a spec that we could all use. So then in March of 2018, just a few months later, we actually, you can tell from the attendance, the popularity was gaining, because it was pretty clear that this was going to happen. So what was really cool about the US Summit in San Jose in March was we actually had hardware on site. So we had hardware from NIC manufacturers, system manufacturers, some of it actually functional. So this was the first NIC 3.0 hardware that was produced. So from September to March, that's when that production took place. So it was very fast. And we are still defining the spec throughout this process. So it happened very, very quickly. And we did actually take on a bunch more community engagement from this event as well. So coming out of this event, we actually made the spec even better because we got more people to kind of sign up to help us out. So let me talk some about the NIC 3.0 form factors. There's actually two form factors included in the spec. There's what we call a small form factor, which is the guy on the right here, and the large form factor. They both use a SFF TA 1002 connector. So these are available in straddle connectors or right angle connectors, but they're basically parallel to the main board. And the large form factor has 4 times the throughput of a NIC 2.0. The designs also can contain EMI containment. So that was one thing from the system vendors that we always struggled with actually on 2.0. The EMI containment was very difficult because this thing was just a PCB basically with very little mechanical attachment on it, and there weren't any hooks to apply a good EMI containment strategy, and you kind of had to fish it into the systems, which was kind of difficult. So we went to more of a modular approach that's kind of a front load sort of approach. So instead of the card coming down like this, you actually load it in like a proper module now. And we also have, we can support a lot more power in these. Just the one main benefit that we got was flipping the NIC 2.0 over basically. So when we went to 3.0, it being upright like this, we could also fit much larger heat sinks on these because we didn't have the connectors on the side here. So just to give you an idea of kind of how much work this took, just from October to June, there's actually been a lot more work done even past this. If you look at the number of general spec meetings, the number of mechanical only meetings, so we kind of all split up into our groups and to divide and conquer on this. So we had 3 leads. We had a kind of a double E lead, a mechanical lead, and a thermal lead. And we split up the project in order to really focus on those areas. And out of that, we have one specification with all the mechanical 3D CAD, all the thermal simulation stuff, as well as a spec that defines all the pinout, all the communication that happens between the baseboard and the NIC as well. These are just some of our contributors. This list is actually a lot longer now. So this was actually from the OCP summit earlier this year. So again, we had to add many more because it was getting too big to deal with. So to give you an idea of where we're at right now, so the first release was January 25th, 2018. That was a 0.7 release. And so right now we're at 0.9. So we're actually working on 0.9 right now. We anticipate to have the 0.9 release probably this week, it sounds like. This week or next week probably. And that's going to add a bunch of signal integrity stuff as well as some small mechanical tweaks and some additional information about the thermal jig, I believe, as well. But our target is to do a 1.0 release at the end of this year. That's what we're trending to. So next I kind of wanted to go into some of the adoption. We sent out a survey about a week ago that was really interesting. So this is hot off the presses. This is some of the data that we got in that survey about adoption of 2.0, because it's something that we never really done. We'd asked around, but we didn't do it formally. So we sent a survey out to formalize this, and we got 23 responses. So this kind of gives you an idea of the mix of NIC suppliers, system suppliers, and end users. So it's a pretty healthy ecosystem, and there's a nice healthy mix of people committing to using NIC 2.0 today. And notice that date is 10/1, so that was yesterday. Pretty new. So of the people that responded, so these are NIC suppliers, so if you notice it says 5 responses. It says, are you shipping NIC 2.0 NIC as of today? And 80% of NIC suppliers that responded are shipping 2.0 today. So that shows pretty healthy adoption. Keep in mind, this is 2.0, not 3.0. This is kind of talking about the length of time that NIC vendors have been shipping 2.0. So the one big takeaway about this is that it looks like it's increasing to us. So if you look, you have 50% were pretty early adopters. Then the other 50% just came on later. So this is just more recent. So it's kind of accelerating. So I actually quite like this pie chart. It's the 100% pie chart. Basically, all NIC suppliers that respond to this survey said that they were definitely moving forward with NIC 3.0. So it looks like it's being adopted, which is great. So this kind of gets at system vendors deploying systems with 2.0. So 78% of the people that responded to this survey, so in this case it's 18 system folks responded to this, and 78% of those folks actually deploy with 2.0 today. This is kind of a breakdown of deployments over time, I guess. So you can kind of see you have these early adopters, the folks that were the blue and the red. Here are the early adopters, and then you see everybody else piling on kind of after the fact. So it did take some time to gain some momentum around these. I think that's pretty natural. We're hoping that now that we've done this a couple times, 3.0 should hopefully have better adoption much sooner, now that they're seeing the benefits of this. So this is the big question. Do you plan to design a platform supporting NIC 3.0? So of the 18 respondents, 50% said yes, and 44% said evaluating. And then there's a small pie there that says no. So if you're one of those, I'd love to talk to you. Okay, So I think that's about it for kind of the program side of things. We can delve more into the mechanicals so you can understand more about kind of how that's going to affect your day-to-day life, how you design systems around it, how you service those systems. First, kind of a quick thing, comparison from 2.0 to 3.0. So if you notice the 2.0s on the side here and 3.0s here on the right, you can see how the board size increased just slightly. The expansion direction, that actually has to do with the large form factor. So in MES 2.0, we didn't actually have a second form factor, so that's NA. And again, the connector style is a MES connector for the 2.0, so it would mount vertically down onto a baseboard. Whereas for NIC 3.0, it comes in through a back panel or front panel. So it's quite a bit different. So the installation actually kind of alludes to that as well. We do have some availability for hot swap to be built in. So this was actually one of the really hard things because it's not very typical for a NIC to be hot swappable. So we had a lot of discussions around this. So I think how the spec's written today, it allows it, but it also allows you to remove the hot swap circuitry in case of a very cost-sensitive case. But I'm not exactly sure how it's written in. It's a bit out of my wheelhouse. So again, the EMI containment was a big difference too, where it's pretty difficult to do a really good job of containing the NIC 2.0, where 3.0 actually has it built in to the spec itself. So it really lowers the barrier for design. You're not having to design different implementations for every single chassis. The implementation's the same on every chassis or just slightly variants of, but it's not a new thing every time. So the system vendors seem to really like that. So here's kind of what it looks like. This is actually an excerpt of the 3D CAD. This is kind of my chassis, my simplified chassis. So NIC 3.0 slides into it. There's some card guides on either side and a straddle connector at the back here. I'm not going to go through these goals. These are the mechanical goals that we used to define the mechanical stuff that we all agreed upon at the very beginning of the program. It was really important to have that common ground going forward to really understand what the goal was and how we're going to set out in doing it. And if people wanted to deviate from this, we had to have some long discussions about why, because we all agreed on these real early on to help drive the design. So some more about the module configuration. This is just a small form factor. The large form factor is very similar, but we took this because this is actually the high volume use case. So again, increased total PCB space, simplify component key pins. That's actually something we hadn't talked about. In 2.0, the one thing that was really, 0.5 and 2.0, the one thing that's really interesting is the keep out zones on these cards were actually very complex. So you had kind of different zones with different heights and all sorts of weird things around these because of the life that it had previously. So in 3.0, we were very determined to go to a very simple keep-in zone. So it's just a rectangular box with 11.5 height, across that footprint. Very simple. And also there's a bottom side keep-in as well. Again, built-in EMI containment. Those mechanicals are actually built in the spec. So you can download the mechanicals, they're available, and NIC manufacturers are actually building with those mechanicals today. And it's available in 2 versions. Technically, it's 3 versions now. It didn't make this deck. We have a toolless configuration with a latch, and we also have a thumb screw configuration that's shown here. So this has a thumb screw on the right and a pull tab on the left. So some about the module size. So the module, the main thing to keep in mind are the column on the left, the PCB size. So we have the small form factor at 76 by 115 and the large at 139 by 115. The large is almost double the size of the small form factor. They each have the same card guide keep out on the left and the right side. The mechanical interfaces between both large form factor and small form factor are almost identical. Just wider with an additional connector. Okay. So here are a couple of the module versions for the small form factor. On the left, you have the single pull tab version, and on the right, you have the toolless latch version. Technically, there's a third one out here too, which is an internal locking version. It's in the spec. It didn't make this deck, but it pretty much looks like all these without any of the pull tabs or latches included. When you see these all have the worst case modeling configurations. So the QSFP is shown with a 2x configuration to just show that you could fit 2. If you only needed 1, you just depop 1 and fix your mechanicals and you'd be set. Same thing in other cases. We model everything worst case, so we're sure that we can support the need of the community. That's how all the modeling's done. These are the large form factors. Again, there's not much new here. It's just wider. There's an additional, for those of you that are familiar with the sliver connector, on the right-hand side, the small form factor side, if I go back, let me go back one here. So on the right hand, this is the right-hand side right here of the large form factor. That has what we call a 4C plus. So it has a 4C connector plus some additional sideband for the OCP implementation. And what we do in the large form factor, is we add an additional 4C on the left side. So that's how we get our additional by 16. So it just grows the width. The mechanicals are all very similar, actually. The latch it's all the same profile. It's just longer. The lock's the same. All the EMI containment's the same. It's just a physically wider module with higher power ability as well. These are kind of what the chassis examples look like of the two main chassis implementations. We have a straddle mount, which is the top, and a right angle mount, which is the bottom. So the straddle mount, you need a big cutout in your baseboard in order to sink it into the baseboard. For the right angle, it actually exists above the baseboard, so you could route under it. For most one RU servers or OU servers, typically they always use a straddle mount because they need to fit a PCIe slot above, so the height's really critical. But there are some cases where a right angle might make sense as well. So next I'm going to just quickly go through the thermal stuff, and hopefully we'll have time for some questions here. Are we doing? Okay. So I kind of alluded to some of these things earlier. The updated NIC 3.0 provides more space for the connector just due to removing the additional connectors on the side, so we can actually widen the heat sinks up. Excuse me if I misspoke. The large form factor also allows for much bigger components, ASICs, FPGAs, memory, things like that. This is an example of what's included in the spec. It's basically this is the cool IL case. So we show guidance for cool IL, how much flow you need in order to support cool IL powers. We also have the same for the hot IL case as well. All this is included in the spec. You can find it there. The other thing that we've done is some of the community partners actually got together and created a thermal test fixture. The one thing we commonly run into with testing these is we all are kind of talking different languages when we're trying to relate why we have problems. So this test fixture allows us to test using the same conditions on a wind tunnel, so we can better understand, what the system vendors need, what the NIC manufacturers need to produce, and we're all kind of talking the same language. So that's an addition that's included in the spec as well, and those jigs are available too. So just to wrap this up, this is our schedule. Again, we expect a 0.9 release here in the next week or so, and 1.0 the end of this year. I did want to kind of point to these links right here. These are where you can get to the spec. So when you click on those links, you'll be able to get to the spec. You can download all the 3D CAD, all the thermal stuff, everything's there, and it's updated on a pretty regular cadence. So you will actually see some additions beyond these that are kind of more incremental additions. So with that, do we have time for questions? Or okay. So with that, that's all I had. Any questions regarding 3.0? we need a mic for him.
Yeah, just a question about, so it's set up for Gen 4 PCIe. How about Gen 5? Any plans there?
It's definitely something we're working towards. Yeah.
Okay.
Thanks, Joshua. This is an excellent example of how the community can come together, collaborate, and actually work on common problems. So up next, we have Whitney, who will be presenting some server and machine learning system updates from Facebook. While she is getting set up, if there are any last questions for Joshua before he heads out? One quick question for Joshua.
Is the card power envelope limited by the terminal or the connector power?
So the powers that are listed there are more like the powers that can go through the connectors. There is some debate. So we put a lot of headroom in those numbers. So we want to have a lot of additional power to give you guys a lot of flexibility to do other things. So the thing about that is, depending on your implementation, if you're cold aisle or hot aisle, it really changes what you can do, right? So, but those numbers that are shared there are more of a kind of a contact, a maximum contact power, right? From the sliver connector into the NIC. Yep. Cool.
Excellent. Thank you.
Thank you.